Today we're going to discuss the newest addition to the Rocketry Workbench, and that is calculators. Now, these calculators are accessible anytime you have your workbench set to the Rocket Workbench. You don't need to have an active document, although I have one here. It's accessible either from the toolbar or from the Rocket menu under Calculators. Okay, so let's look at them each in sequence. We'll start with the ejection charge calculator. So this is intended to calculate the amount of black powder you require in order to deploy your recovery system. Now, there is a warning here, and it emphasizes that this is just an estimate. You do need to test on the ground, typically starting with a small value and working up until you are certain that you have enough black powder to eject the nose, deploy your recovery system without putting too much in and either shredding your recovery system or doing permanent damage to the rocket itself. Okay, but be aware that this is just a preliminary calculation. If you rely on the values in this calculator, at some point you are going to be disappointed. You do need to test before you fly. Okay, so with that warning out of the way, let's look at what we're calculating. So the first thing we have to do is figure out the volume that we're trying to pressurize. So if your parachute is in a compartment, such as for my level 3 system, 4 inches long, or 4 inches in diameter by 36 inches long. Okay, now in my case, those weren't the actual dimensions, because at the front we had the shoulder of the nose cone, and at the rear we had the shoulder of the electronics bay. So instead of 36 inches, this was more like about 28 inches. Okay, so we'll do our calculations accordingly. Now the force. If you go on to most of the sites discussing this, you want a force somewhere between 150 and 200 pounds force. The conversion in FreeCAD is actually incorrect at the moment. I have merged a fix to this, but it hasn't made it into the builds. So you can't enter the value in pounds force yet, but you will be able to soon. In the meantime, I have a couple of presets. So the low is the 150 pounds force, and the high is the 200 pounds force. And you're going to want something in that range. Okay. So once we know the force, we can calculate the pressure we need inside the body tube in order to generate that force on the nose. And from that, we can calculate the amount of black powder required to generate that pressure. Okay. So at the low end, we're looking at about 2.3 grams of black powder. And at the high end, we're looking at about 3.1 or 3.05 grams of black powder. Okay, so again, when you're testing, you want to start low and work your way up until you get the sufficient amount of black powder to eject your recovery system. Okay, so again, test before you fly. Next up, we have parachute size. Now, as far as parachute size calculators go, this is pretty simple, and it's certainly one that I can see being improved over time, but it certainly gets the job done. So what you would do is enter, first of all, a rocket weight. So again, let's take an example that's in the high power range, 12 kilograms. The terminal velocity. So for a main parachute, you want something that is going to descend at about 20 feet per second, which corresponds to 6.1 meters per second. Okay. If you have a drogue system, so if you're doing dual deployment, you want to descend in the 60 to 70 meter per second range. Okay. So for the drogue, I have that preset to 19.8 meters per second. Okay. Let's go back to the main. The drag coefficient. So I have two preset values in here. One is for basically flat sheet parachutes. So what you would get from your typical model rocket kit would certainly fall into that category. So and that doesn't matter if it's round, hexagonal, square, whatever, it's going to have the same drag coefficient. Now, if you've got an actual dome shape, so not just a flat sheet cut round, but one that's shaped as a dome, you're going to get a drag coefficient of 1.5. There are other designs out there that have higher drag coefficients, and the manufacturers of those designs are certainly going to have that information available for you. So we can accommodate most parachutes using this. But as we can see from this calculator, for a 12 kilogram rocket, the main chute is going to need to be 2.1 meters in diameter. Okay. Now, if we go to a low power example, let's say 68 grams, with your standard sheet parachute, then you're going to want to be about 220 millimeters in diameter, 223. Okay, so nice and simple calculation. Thrust to weight. This is another simple calculation. In fact, this one is very simple. What this does is give you the minimum thrust in newtons required for a given weight of rocket. And it does this with just a simple 5-to-1 thrust to weight ratio. Okay, so this thrust is going to be the average thrust of your rocket, not the peak. So for example, going to my low power example from earlier, a 68 gram rocket will require 3.3 newtons of thrust. And the 12 kilogram rocket will require an average thrust of 588 newtons. So this is where you can look at your motor charts to see what satisfies those needs. Now you're going to want to simulate to get the full performance of the rocket, but this will give you a good idea of where to start. And the last calculator, when you're building an electronics bay for a rocket, you need vent holes for any barometric flight computers that measure your altitude based on decreasing pressure. So if you don't have vent holes, you're measuring the pressure inside the rocket and not in the outside air. So you need vent holes in order to allow that pressure to equalize. And the size of the vent holes depends on the volume of the portion of the rocket that contains your altimeter, and of course the number of holes that you have. General rule of thumb is a minimum of 3, but you can go higher. So let's look at the example from my level 3 rocket, which was in a 4-inch body tube, and it had a length of 12 inches. Okay, so with 3 vent holes, I needed a minimum vent hole size of 4.5 millimeters. I had 5 in mind, so I'm certainly covered here. But we can see as we go up in size, if we have 4 vent holes, we can get away with a 4 millimeter hole, and so on with decreasing returns. So you're probably not going to have 10 vent holes. Okay, but a nice simple calculation to make sure that your altimeter works correctly. So these are the calculators available in the current release of the Rocket Workbench. There's certainly room for improvement in all of those calculators. We can add a lot more different scenarios to them. So if you have any ideas of things you would like to see in either the current calculators or perhaps a new calculator, by all means leave a comment below, or you can enter a suggestion via the GitHub issues page. Either way, all suggestions are seriously considered. As a general rule, these calculators are pretty easy to implement if we have the information required to make those calculations. The next release is going to be a little bit longer in coming, but it's going to have a lot more features to it. So I'm pretty excited to show it to you. I've teased with a bit of a preview on Twitter, but yeah, watch this space. There's a lot more excitement coming. So in the meantime, have fun building and have fun flying.